Hi, my name is John Fox, and this is my project, The Slippery Solution. Let's slide in. The question that really prompted this project is I grew up in West Texas, as well as I go to school here in Oklahoma, and a central focus of the culture here is oil. It's a big part of our social lives, our economic lives, our political lives. And so one big thing that environmentalists really focus on are oil spills. It's a big prevalent issue in the environmental field. And so really what I wanted to try and see is what sorbent, so what material that is absorbing the oil, what material, what sorbent is the best at cleaning up oil spills. My hypothesis for this test is that the cotton balls are going to be the best at cleaning up the oil spills. So one really unique thing about cotton is that they have this thing called capillary action, which means that the oil will flow through the fibers of the cotton and really just hold on and grasp on there. Additionally, natural cotton has this kind of waxy coat over it, which allows it to repel water but also absorb oil. So these things make me think that cotton will be the best absorbent to clean up the oil spill out of all of my materials. So how this science fair project was conducted is that we had 3 sorbents. So the cotton balls that we already discussed in the hypothesis were one sorbent. And additionally, we have the shop towels, and I used grass. So I got all 3 of those, I gathered them up, put them in their separate bowls. And then following that, I made an Excel sheet on my computer. And so what that entailed was after the 30 seconds that the sorbent was in the oil and water mixture, it talked about the oil, the total level of water and oil combined after those 30 seconds, as well as the remaining water level, since you can tell that due to the oil and water being separate. And then doing some math, we can find the total oil level as well as the ratio of water to oil. And so after that Excel sheet was made, that's the time that I actually set up the lab. And so initially I got a trash bag for cleanup, as well as I got a measuring cup. And so it was 3 parts water, 1 part oil. So it was 1.5 cups of water and then 1/2 cup of oil. Now it's really important whenever this lab was setting up that I made sure that the vegetable oil wasn't poured in too quickly, because as we talked about earlier, water and oil don't mix together. They lay on top of each other, or the oil lays on top of the water. However, if you pour it fast, that level gets a lot of bubbles in it, and it can hinder your results. So after that was set up, I had my two cup measuring cup full. I got my first sorbent, which the first one I did was shop towels, and I cut them all up to make sure that they could fit into my reusable coffee filter. And so what happened after that is I filled up the coffee filter and I placed it into the oil and water mixture and set a timer for 30 seconds. And so after those 30 seconds were up, I took the reusable coffee filter and the sorbent out of the mixture and put it in my trash bag. And I let it settle down a little bit, and then after that I took my results. I measured the entire level and then the water level and did the math afterwards. And so for each sorbent, I did 3 trials of each. And then so I had 3 sorbents, so 9 trials overall. And then after that, I went to my spreadsheet, I looked at my results, and we'll get into that. Before we go to talk about results, I want to talk about the observations that I had during the trials. So like I said earlier, the first sorbent that I tested, the first 3 trials, were shop towels. So initially, it was kind of difficult because shop towels obviously can't fit into the reusable coffee filter. So I had to cut them into strips so they could all fit and I could use the most space. And so I dunked them in for 30 seconds into the oil and water mixture. And then after that, initially, it seemed that the shop towels soaked the oil and water up very quickly and not very progressively. And then once the 30 seconds expired and the filter was removed out of the mixture, there was a significant excess of oil and water that dumped out, which made me think that the shop towels got oversaturated very quickly. And then after that, I did grass at the end, my last 3 trials. And so as the grass was initially submerged into this mixture, there didn't really seem to be any change of level. However, when I pulled it out, there was a lot of excess that came out with the grass, a lot of excess, more than the shop towels. And so that was really interesting to me. However, it did a lot better than I assumed as we get into the results, but there was a lot more excess that came out of that mixture for 30 seconds than I anticipated. And then over here we have the cotton balls, and the cotton balls were the sorbent that fit into that took up the most space in the reusable coffee filter. So they really used the most volume that was allotted to them. Also, they're very workable and moldable, as we know. And so when the filter and sorbent were in the mixture, it seemed to gradually soak up all the oil and water, and it wasn't as quick as the shop towels were. And after the timer rang and I took the filter out with the sorbent in it, there was a lot less excess oil and water that drained out compared to the other two, a significant less. Also, the filter felt significantly heavier than the other two, just what it seemed like to me at the time. The amount of oil and water that had actually been soaked up by the cotton balls was significantly more due to the weight that I felt. So let's get into the results. So these are the data tables that I had made during the trials, and kind of shows the results of what we got. So see here, the total level, so that was the total level of water and oil combined. We have the remaining water after the sorbent, since you can see that. And then after that we did some math, so the remaining water after the sorbent plus or minus the total level will give you the remaining oil level, because that's all that's left, right? And then after we did the ratio, so that's going to be the remaining water over the remaining oil, so that kind of gives us the ratio of water to oil. So as you see here, I think the most critical thing that we can find is that was the most consistent out of all three. As you see here, the total level is always 1.5 cups. All three of the trials were the same. Rather than the other two, were a little more spaced out with the results. So that was really refreshing to see. So here's another form of the results that we got during the lab. As you see here in the remaining oil level, you can see that cotton has the lowest numbers out of all three. There is an outlier in the first trial, but that's why we do 3 trials. But when you take the averages, as we'll see in a minute, cotton was the lowest average on the remaining oil level, which is a good thing. And then here we have the oil and water ratio. We also did it as a bar chart. You can kind of see they're all over the place a little bit. But as we get into the results, a more quantifiable thing, you'll see that actually grass did the best when we had the remaining oil to water ratio. And so here in the results, we'll talk about the shop towels. They had an average ratio of 4. And then going to the grass, we actually, taking the mean of all the ratios, had an average ratio of 4.46, which was the best out of all 3, which I was very surprised about, actually. And then the cotton balls here in the middle, they had the average ratio of 4.33. However, the average amount of remaining oil left after 30 seconds was 2.91 cups, which was better than all 3 of the sorbents combined. So in conclusion, after looking at the hypothesis, reviewing that, going over the procedure and looking at this data a lot in the observations, really going back to this hypothesis here, what type of sorbent is the best at cleaning up oil spills? And I said cotton balls were still the best. While grass did have the highest ratio of oil to water, cotton balls they did the job that we looked at initially, which was cleaning the most oil out of oil spills. Even though they also took up more water than the grass did, they still picked up the most amount of oil, which is really what we were looking for. So ultimately, our hypothesis was correct in this lab. So after doing this lab and going over the conclusion and doing the entire thing, I really wanted to reflect and think about the errors that I might have caused, as well as some considerations to really advance this project and make it more dynamic. So some of the errors that I think that occurred was the excess that I talked about in the observations and what to do with it. I didn't know whether I should have let it drain all the way out or just pull it out as fast as possible. So that's definitely something to consider and make standardized next time this project is completed. As well as the timing. 30 seconds seems very quick, and sometimes that 30 seconds might have been 35 seconds or 33 or 28. So kind of making that standardized as well, and making sure that the exact time the sorbent touches the oil, that's when you start the timer and things like that. So making that more standardized, as well as making a larger system. Initially, this project could have been doubled with the ratio of water and oil, so 3 cups of water and 1 cup of oil, to really make a larger system and to make it more uniform and kind of help the sorbents do their thing. Some considerations that I also think that would be important to consider if this project is done again is measuring the sorbents by mass and not volume. So that's one thing I also noticed, is that while the cotton balls were easy to measure by volume, it wasn't as easy for the grass and for the shop towels. So that'd be something that would definitely probably advance this project and kind of get you some more stable numbers. So I think that's definitely something that would be beneficial. As well as, I use sorbents, while cotton and grass may be environmentally conscious, shop towels aren't. And so really redoing this project, but adding a more environmental spin on it, and kind of only use sorbents that would be environmentally safe. So using things like potentially sawdust or hair, things that have already been in cahoots and talked about when cleaning up oil, but making a project purely with environmentally safe sorbents. And so I think those are some really important considerations to take into account. But overall, I think this Science Fair project went really well, and I'm glad I did it, and I hope you learned a thing or two.